Good morning, everyone. Welcome to the webinar on improving operational efficiency in AEC with data integration. I'm Erin Lemke, and I lead the product marketing team here at Safe Software.
I'm Vivian Tan. I'm on the product marketing team as well.
My name is Javita Chan, and I'm a desktop technology expert.
And behind the scenes here, we have Dave as well, who's going to be helping on Q&A. So you'll see some answers coming in from him as you ask them. And so now what we'll do is now that we've kind of introduced ourselves, we're going to turn off our cameras and get going on the presentation so that it doesn't take up quite so much bandwidth and you guys can hear and see us all well. So we'll turn those off and get started here. So today what we're going to do is walk you through the data challenges we most often see for architecture, engineering, and construction companies, and how data integration can improve operational efficiency at each stage of the project lifecycle. So we'll start by showing an example of a project from an engineering firm in Australia, and then we'll provide a short overview of who we are and what we offer so you can understand kind of where we fit into the market and where we're coming from. And then we'll go through kind of how data integration can help in each stage of the AEC project lifecycle. And for each stage, we'll talk about some customer stories and resources so you can get started. And our demos today that Jovita is going to provide are going to include CAD to GIS, LIDAR to 3D, and integrating data for facilities management. Make sure that you send in your questions as we go, because we will be doing a live Q&A at the very end, and we'll kind of see if we can summarize some of the most popular questions that have come in. So if you just go into the panel on the side of GoToWebinar here, you can ask your questions there in the questions chat as we go along. So now that we have kind of talked about what's coming today, we just wanted to ask kind of where you're coming from. So which best describes your company's offerings? Do you provide full service engineering consulting? Are you a construction company? Do you work at an architecture firm? Do you provide surveying? Do you offer geospatial solutions and system integration? And we found that a lot of customers of ours actually cover off like some of those boxes. So feel free to check all the ones that apply. We do find that a lot of people do geospatial solutions and system integration alongside others. And yeah, see, we have a lot of them coming in like that. We've got a lot of surveyors, lots of full service engineering consultants. We've got construction. So lots of you are doing geospatial solutions and system integration. And lots of engineering companies, surveyors, construction, some architects. Yeah, that is kind of consistent with what we see day to day as well. Thanks for sharing that. So now we'll hop over to kind of giving you an overview of some of the data challenges we see every day in those industries.
Okay, so first, let's talk about some of the data challenges AEC companies have been experiencing for a long time. Due to complexity of projects with various stakeholders involved in using different systems and applications, project data can end up in silos, making it hard for stakeholders to access and use data when, where, and how they need it. Another challenge is the lack of automation in project workflows in the AEC industry in general. To overcome these challenges, you need a data integration solution. Let's take a look at a customer story from Arab Australia and see how they solved their data challenges when working on the Sydney Light Rail expansion project. When starting on an AEC project, engineers need to bring together existing infrastructure data from various sources, including local government, field surveying, utilities companies, in order to have a holistic view of the site environment. In this case, a team of 8 engineers were tasked to manually identify underground utilities that clashed with the new proposed railway route. The team was given numerous data sets from various stakeholders, including city mapping data, GIS, CAD, 3D asset information, survey, and design data. In addition to the data challenges, the utilities corridor below the surface was at 85% capacity, so there was very little room for error. The engineers knew that manual option was going to be a long, tedious process. They would have to convert each data set into a correctly scaled 3D model, and then manually stack the layer on top of each other to identify the clash. With FME, they were able to automate the process by creating a reusable workflow that integrated all of the data sets and applications, and having it updated each week as new survey data came in. This helped the team significantly reduce manual workload, allowing the engineers to focus on their elements of the design. In the end, they were able to provide 2 outputs for stakeholders to review: a solid 3D model that visualizes the clashes, as well as a web interface showcasing the network app, which can be clicked and viewed in detail with attribution. These outputs were shared with the 25 utility asset stakeholders, including Sydney Water, Australia Origin Energy, Vodafone, and Verizon. The data output in the workflow was so valuable that many of the asset owners requested a copy of the enhanced data to improve their own internal utility network systems. Arup continues to use FME to support many other AEC projects.
Yeah, that's pretty incredible when a project is so successful that the vendors actually ask for the data that's better quality than what they had to begin with. What we do at Safe Software here is we help organizations like yours maximize the value of your data, and we don't really worry too much about where it's stored or what applications you use or what you need to provide access to. We want to hear from you where you want to have data supported, and then we make sure we support you there. So we support over 450 different systems and applications, and Safe Software was founded in 1993 by our two co-founders, Don Murray and Dale Lutz, when they recognized that local companies were encountering a lot of data challenges in 1993, and they set out to help. So today, our data integration platform, FME, enables over 10,000 organizations worldwide to use and share their data where, when, and how it's needed. FME is known for its ability to address complex challenges posed by location information and provides the best support for spatial data in the world. We're a software vendor, so services are provided by our network of over 150 partners. And we're working with over 1,000 customers in the AEC sector around the world, from multinational engineering consulting firms to small service providers, and companies of all sizes can benefit from using FME to solve data challenges. So for those of you who are new to FME, I'll take a quick moment here to introduce the products that make up the FME platform so that you know where we're coming from and so that you can follow along with the demos today. So FME Desktop on the left there is the authoring environment where you build your data integration workflows. That's where you design the details surrounding what the data sources are, how it needs to be transformed, such as the data schema transformation or coordinate system reprojection or filtering the data, even in a spatially aware way, and then writing it out to the required destination system or applications. Where FME Server comes in is the automations. So using a GUI that we interestingly enough call automations, you design the ways you want your workflows to run hands-free. And it's important to note that we also offer flexible deployment models for FME Server, one of which is FME Server deployed in a fully hosted cloud environment, which we call FME Cloud. And when we talk about FME Cloud today, we're talking about one way to deploy FME Server. So as you can see in the images on the screen here, all of the product environments use a visual interface and there's no coding required.
All right, so before we dive into each stage of the AEC project, we'd love to know from you, what are the data challenges you're facing in the AEC project lifecycle today? What software and data formats do you work with? Please feel free to send your feedback in the question panel as we go. We always value insights from our customers as they help us improve our products to better serve your needs. So please do let us know in the chat. So the key takeaway here is that FME helps AEC companies increase operational efficiency throughout the project lifecycle by integrating data across teams and systems, streamlining project management with automated workflows, and making data accessible to stakeholders who collect and use the data. We will walk through 3 stages of the AEC project lifecycle and see how data integration and specifically FME can help maximize the value of the data and increase operational efficiency at each stage. At the planning and design stage, different groups of stakeholders are involved in the project workflow and the decision-making process. These groups include interior designers, urban planners, engineers, surveyors, and a range of other professionals, each with their own set of tools and software. With FME, you can integrate data sets from disparate sources, including BIM, CAD, GIS, point cloud, field survey, and more, and extract only the information you need for your project. You can also automate data transformation workflows and validate the data without losing data quality. Some of the common workflows include transfer CAD to GIS, combine BIM and GIS, and transform LIDAR to 3D models. Moreover, you can streamline your project management with automated workflows to reduce time and efforts on manual tasks. For example, you can create a central data store with all project documentation and communication, and set up auto updates so that people who collect and need the data can easily share and access the most current version of the data to make informed decisions.
Yeah, and some of the examples that came in here are, for example, Revit and IFC, and HOK has been working with those. So let's look at an example here of a situation where automating data integration makes a big difference. So HOK is a global design, architecture, and planning firm with over 1,600 employees and 24 offices located in North America, Europe, and Asia. And they were tasked with modeling approximately 2 million buildings for a 130 square mile city. This project would have involved input from multiple groups and their different software applications, including Autodesk Revit and Esri City Engine. And to get the job done, they needed a better urban planning workflow to integrate this disparate data into a unified format that would best suit their modeling and presentation needs. So HOK used FME to execute data manipulations that were not possible using BIM and GIS applications on their own. They could extract subsets of data, add attributes, derive new values, and execute many other complex operations. And in the end, they were able to achieve transformation and integration of data in Revit, Shapefile, IFC, AutoCAD Civil 3D, GeoTIFF, IMX, and many other formats, and automatically generate 3D buildings without writing any code. The resulting workflows save immense time and effort while retaining intelligence from the existing information. And after successfully using FME to accomplish the city modeling project, HOK started exploring how FME servers' enhanced automation capabilities could be used to streamline their BIM workflows and company-wide data management processes to ultimately save time and improve the quality of data being used in decision-making around their entire global network of offices.
Here we have another story from T. Baker Smith, one of the top 500 engineering, architectural, and environmental design firms in the United States. They needed to create a company-wide standardized data store for information collected in the field to make it more accessible. The problems with the traditional survey data collection process are there is no company-wide standard schema for data collected, no auto-generation of drawings, no centralized data store, and no data transformations for recurring processes. To solve these problems, they use FME to build workflows that input and map field survey data to the centralized data schema and format, perform quality assurance checks, manipulate the data for storage, and extract the data from the data store. Users can extract data via a viewer or FME server and specify output data formats to DWG, SHP, SDF, and KML formats. With FME server, they were able to automate these processes and make them available to both the field crews that collect the data and the end users of the data. The data is now easily available to users both inside and outside the company. The central data store is updated about once a month and replace individual project folders, so everyone can access the most current version of the data from a single place. The automation of the process saved them a great deal of time and efforts. Although this sounds like a dream scenario that requires foresight and buy-in, and the initial setup requires some planning, as we see from T. Baker Smith's story, once the process is automated, it benefits everyone. Now that we've talked about a few data integration scenarios from the planning and design stage of the project lifecycle, let's hone into CAD to GIS specifically. Let's imagine you're a GIS professional working in an engineering firm, and you need to put together source data sets, for example, parcel or utilities data, and clip them to focus on only the data you need. You need to build you can build an automated workflow so someone can just drop the files and run it without even having to build it from scratch every time. In fact, the end user doesn't even need to touch FME at all. They just need to upload the files on the web form and the downloaded output directly. Now, Jovita is going to show us a demo on creating this type of workflow using FME platform. Jovita, hand it over to you.
Thanks, Vivian. So let's first take a look at the source data going in. So imagine we have our parcels data as lines in AutoCAD, and we also want to grab some utilities data for this target extent. So perhaps my GIS person has it, or it's somewhere external, but we can bring that data together and grab my utilities as water distribution mains in GeoJSON and clip that extent to our target parcels and write that out into file geodatabase. So I'm going to hit next here. This is just a close-up. We're looking at the city of Vancouver. In particular, my parcels are in the West End in downtown Vancouver, if anybody knows it. And I do want to point out that my parcels are lines, not polygons. And that's something that we can clean up in our workspace to create polygons out of topologically correct lines. And we can also, oops, excuse me. And we can also preserve all of our attribution data. In the table view on the bottom here, and this is a screenshot from the data inspector, which is part of the desktop product, I have some of my attribution data on my water mains, which was GeoJSON, and in my neighborhoods, I've got some IDs of the neighborhood. And I hit next here. And I'm going to dive into Workbench now. So this is FME Desktop. For those of you who are less familiar with it, this is where you connect your data sources, transform your data using transformers, and then output your data into where it needs to be. So what this workspace is doing is that it's taking my source data, which is AutoCAD parcels, and GeoJSON lines, which are of my water distribution mains, and we're clipping the larger GeoJSON to the extent of my parcels in order to get file geodatabase of just the extent that we need, cleaning up those lines into polygons. And I just wanted to quickly add, because when you're looking at new software, sometimes it's just nice to know how to add things. You can add your readers and writers through these buttons, or just start typing directly on the canvas. And there I've got my area builder. Gonna head back. Actually, before I go, we're going to now look at automating this CAD to GIS workspace. And in order to connect to FME server, which is where you can automate this workspace, you can hit publish here, connect to your server, register your service. And for this one, I've got a data download service. And now we're going to head over into FME server, which is on the browser. I'm going to click this link. With FME server apps, you can create a web form in order to run this workspace, and then share that URL with either people in your company or people outside of your company. You can also set permissions in order to restrict access, so only the people who have access can use it. So this is my web form for Add to GIS. And I'm going to go to my data folder and grab that West End parcels in AutoCAD. And this can be any other parcel, set of parcels that overlap that area. And I'm just going to drop that in there. I'm going to hit OK. So what this is doing is it's running that same workspace that I just showed you. That's what's powering this FME server web form. Another option to automate that doesn't require a step for somebody to press OK or drop a file is to use automations, which allows you a set of different triggers in order to run a workspace, whether that's a schedule that you want to run weekly, daily, or monthly, or if you wanted to run it on a trigger such as a directory watch, when a file is dropped somewhere and then you want it to kick off the workspace. So this is completed now, and I can hit this here and I'll download my output as a zip file. I've already got it pulled up here, so I'm going to head back into my slides there, and I'm going to hit next. So this is my output geodatabase, file geodatabase, and this is again a screenshot of the data inspector, which allows you to preview your data and your outputs. And as you can see from this screenshot, or this highlighted square here, or rectangle, I now have polygons rather than lines, which cleans it up, which is a little bit more useful. And then I've got my lines clipped to just the West End. So if you remember earlier, I had all of the city of Vancouver with blue lines, which were my water mains. And now I'm only looking at this small section of downtown Vancouver for the data that I need. So I just wanted to note that in my web form, I had parameters that I could change both inputs. So this would work with more than just the files that I've got here. In my parcels, I've retained my neighborhood IDs, my neighborhood name, and I've got my shape length and area from the writer. I noticed in the chat that people were interested in going from AutoCAD to ArcGIS, and I just wanted to note as well that aside from just file geodatabase, we can also connect to ArcGIS Online and Arc Portal. And then,
yeah, that's a really common workflow that we see a lot. So one of the things that I was going to mention for FME server apps is actually that this year there's now the FME server apps gallery. And so if you want to deliver a bunch of different FME server apps, to people within your organization or other end users of the data, you can do that, and then it can all be permissions controlled so they can just see the apps that actually apply to them, which is pretty neat. Save some time.
Yeah, it's really cool as well because then the end user never really needs to see the workspace, and this automates their CAD to GIS workflow.
That's right, yeah. Thanks, Davida. Yeah, so next we're going to move on to the construction phase. And so while not as hungry to adopt digital as some of the other stages of the AEC project lifecycle, construction companies are starting to incorporate technologies into operations that reduce costs and increase safety. And reality capture and 3D surveying make it possible to perform surveys and inspections virtually. During the construction phase, drones can be used to provide an overview of the site to monitor progress and overall safety. And as construction continues, drone data can be used to create 3D models to verify what's been built at each stage and that it matches the design model. With FME, you can transform large point cloud datasets into rasters, 2D features, and precision 3D models. With numerous ways to manipulate and process your data, you can easily customize your data analysis workflow to make the most out of your point clouds and help you make fact-based decisions. Digital technologies are also driving the adoption of connected construction. So drones, wearables, sensors, and GPS tracking services are revolutionizing job sites and capturing valuable data. For example, you can leverage FME to connect and integrate data from IoT sources to manage labor and material more efficiently on construction sites. Construction managers can assess the status of material delivery and installation, location of workers, and how they are using the machinery in real time. So now Jovita's going to demo a workflow that involves transforming LIDAR and CAD data to a 3D model and converting the model to a PDF file for easy sharing.
Thanks, Erin. I'm going to hit next here. So once again, we want to look at our source data and know what's coming in. I've got my last file also of Vancouver, but this time it's a different part. If anyone's familiar with Vancouver, this is the Granville Island in Yaletown area. So I've got my point cloud there as a .last file. And then I've got my DWG building outlines. So you see those red lines are my outlines, and that's my CAD file. This is my workspace, and it's taking those outlines as DWG and that point cloud. And it's clipping each point cloud to the building, and we're going to use the point cloud to grab the median height of each building in order to extrude those building outlines as solids. And also at the same time, pointing out the point cloud filter here, if your point cloud is classified, we can really easily already separate building points from ground points. So at the same time, we can create a ground terrain model, creating a surface out of that and outputting this into 3D PDF for simple sharing. And this is a reminder for myself to open up that PDF to show you the output. It's way more fun than a screenshot just because it's so interactive. It's just kind of delightful to share. First off, I want to show you that in the model tree, you can toggle on and off layers, so you can set those. I like to turn the ground off just to get a better view. Vancouver is pretty flat, so it's a little less exciting, and it is split by the Fraser River there, which is why it's flat. And I want to show you that in the 3D PDF, it is interactive, and it keeps all the attribution information as well. So I've selected building number 18, and I have my base height, outline ID, and the median height. So this is kind of fun. I'm going to head back into our slides here. And I also wanted to point out that this particular workspace is available with step-by-step instructions. I think this was this one. With step-by-step instructions here that you can check out after the webinar. The slides will have the link to this article. And I also wanted to point out the FME Transformer Gallery. There's lots of transformers to work with point clouds, and you can filter by point cloud and take a look through the possible transformers and tools that you've got to work with point clouds. I'm going to head back into my slides here.
Thank you so much, Jovita. Next, let's move on to look at how data integration can help increase the efficiency in facilities and asset management after construction is completed. Digital twin has been a buzzword in the AEC industry for years, and it's becoming a trend in smart asset management. As a digital replica of a real-world physical asset, digital twins are made possible by integrating as-built drawing from various systems, along with IoT sensors that gather data from the physical world for further integration and analysis. When creating a digital twin of a building, FME can help you integrate different asset data from basic spatial information to added intelligence from disparate sources, including 3D models, floor plans, material information, internal asset management systems you use, as well as external systems. You can also leverage FME to build automation workflows to ensure that the data stored in the digital twin is always up to date. Centralized and visual asset information allows easy use of data and ensures the data is always available to all relevant stakeholders so that they can make real-time informed decisions. With the digital twin, it is also possible to simulate operations and compare historical data to the latest one in order to predict future changes. Another innovative use case we observed is integrating dynamic indoor maps with facilities management system to empower and support facilities management teams to work more efficiently. With FME's best support for spatial data integration, you can convert data from floor plans, ArcGIS indoors, Chiriga 3D, Chiriga CAD, and other sources to create dynamic indoor maps that meet IMDF standards. You can build simple automation workflows to keep the indoor map up to date. It is also possible to integrate indoor map data with your facilities management system to address pain points around work order management and indoor navigation. For example, you can identify the location of the maintenance request and assign it to the closest member of the maintenance team. Our last demo is focused on integrating data for facilities management. Imagine you're a facilities manager. Wouldn't it be great if you could connect asset and IoT data with your asset management system, such as Maximo or CityWorks, so that you can track the usage and condition of assets in real time and manage work orders more efficiently? This can be done with FME by integrating asset data extracted from BIM software into your asset management system to create a digital twin, and then set up an automated service request process so you will be notified whenever updated data comes in from IoT sources. We recently held a webinar series around BIM that provided a lot of information around creating digital twins. You can find them on demand at save.com/webinars. So today, Jovita is going to show us how to make the second half of this workflow with FME, where sensors can trigger a work order to be created with confidence that the digital twin is up to date.
Awesome, thank you. I'm gonna hit next here. So this is an excerpt of a workspace that takes that sensor data, temperature sensor data from an asset in a building and creates a city work order or work order in CityWorks, which is a facilities management application. And we can take what this workflow does is it looks for temperatures automatically in real time over a certain threshold, say 21 degrees Celsius indoors, because why would you want it that hot? And as soon as it sees that it's above that temperature, it can automatically create that work order, and you don't need somebody in between to be looking at this information or having to wait weeks for somebody to respond to it, and it just makes it a lot more efficient. So in order for me to talk about this particular workspace, I need to tell you a little bit more about part one. So part one, how this information comes from the sensor data is through the use of webhooks. So this involves FME server. And I just need to get to the next page here. And webhooks are URLs that can send automated messages in real time to other applications. So that's how we're getting that sensor information. And it makes use of the REST API, which is an application programming interface or method of communicating programmatically with tools and functions already predefined and built into a subset of a larger system. The REST API sends and receives data through HTTP. So we use the HTTP caller to do that, and we get JSON information back. JSON is a format that uses key value pairs. So for example, at the top there in my screenshot, I've got sensor name, and the value of sensor name is sensor 2. The temperature is 40 degrees, humidity 35%. So what's input into our workspace here is kind of part two. We've already received that data. We've filtered it out for temperatures above a threshold. And now we're actually going to take that information and create the work order. So receiving that JSON information, we're joining it with asset data. So the actual information of the sensor itself that's reporting this information. And then we're creating a work order and updating it. And I wanted to mention as well, the full example can be found in the FME World Tour 2020 presentation earlier this year by Holly and Sienna. So I would definitely recommend going to check that out if you're interested in working with IoT data and just getting kind of the full picture of that really great example. So this is my output in CityWorks. I've created a work order and I've propagated some of that information from the asset in order to provide more information. So I've got the asset number, and then I've got a little bit more information about the temperature differences and what to look for. And I'm going to pop over into FME Hub here. I wanted to mention that for this example, I made some changes to write to CityWorks. The original example writes to IBM Maximo, which is another asset or facilities management program. And I wanted to mention that in the FME Hub, we've got a suite of transformers or tools in which you can work with CityWorks or connect to it. And you can find that in our FME Hub. There's also an example of a workspace. So there's also templates and workflows that you can download here. And then I also wanted to show you that we have Maximo. That's also found in the FME Hub. Also, we have articles for both with step-by-step instructions. Let me head back into here. So that's one way that you can take real-time sensor data and automatically create service orders in your facilities managed systems in order to maximize your operational efficiency. Back to you, Vivian.
Thank you, Jovita. So we just want to remind you, for some of those of you who haven't got a chance to send your questions, please do so, as we will have a live Q&A in the end. So one exciting update we want to share is that in FME 2021.0, we're adding better support for event stream processing to make it even easier to integrate IoT and streaming data. So stay tuned. As you can see, data integration plays a significant role in helping you achieve operational efficiency throughout the full project life cycle. By implementing a data integration solution such as FME platform, you can make sure data is connected across systems, teams, and applications. FME's automation features help you streamline your project workflows from documentation to communication and to information update. By making data easily accessible to everyone, your team can plan, design, build, and operate more efficiently and collaboratively. In case you're interested in learning more, we've provided additional resources here to help you understand how other AEC companies are using FME to increase operational efficiency and how you can get started building your own data integration workflows, such as CAD to GIS, point clouds to 3D models, like the one Jovita just showed us, and working with some IoT data. This webinar slide will be available on our website afterwards, so you can check out these resources we linked here. You may also find a variety of resources on our website, including knowledge articles, tutorials, and on-demand webinars.
So before we move on to the live Q&A section today, we're going to take a moment to provide a bit of information for those of you who are already using FME or interested in implementing it. We provide flexible licensing options for every organization, and our perpetual licenses are sold by seat on FME desktop and by engine on FME server. And this one is ideal for small organizations or single department deployments or organizations who prefer ownership models. The one we're finding increasingly popular with customers is our annual enterprise subscription, where you get customized bundles of FME desktop and FME server licenses, which include updates and support for one annual price. This is ideal for organizations wanting to deploy the full FME platform and organizations who find it harder to procure the upfront costs of perpetual licenses. We also have the cloud deployment option I mentioned at the beginning. FME Cloud offers an excellent opportunity for cost savings and flexibility because you can start FME Cloud in minutes, which eliminates hours of configuration time on in-house server environments, and you don't invest in hardware or licensing. When you're ready to move into production, you can choose your preferred deployment model in the cloud or on premises. And for those of you who are providing geospatial solutions or system integration services, you might be interested in our partner program. As a partner, you would gain access to marketing resources and free demo licenses, and we receive technical assistance from Safe Software staff on client calls, advanced topics, and more.
Yeah, here at SAFE, we believe in fully supporting our customers in solving their challenges. So we would highly recommend you to take advantage of our FME community when you're stuck on a problem. Chances are that your question has been already asked and you can find the answer quickly. If not, just post your question to the community and we're sure that someone will be able to help you. Also, we are constantly creating, updating, and refreshing free resources for our customers. You can find lots of live and on-demand training courses, knowledge articles, webinars, and video tutorials on our website, so be sure to check them out. If you need further support, our team of FME technology experts will be able to help. You can reach us by filing a support case when you encounter bugs or have an in-depth technical question that may require a deep dive, or you can take advantage of our live chat support if your issue needs to be escalated.
Awesome. Well, now we're going to move into the Q&A section. So I encourage you to send your questions in so we can make sure that we answer them on the air. We've had a few come in here. One of them is Brittany mentioned needing to work with paper as-built, and that's a really great point. We have customers scanning these documents into PDF and then using them, using FME to digitize them. So with this, you can automatically extract data from geospatial PDFs as well, including scanned plans, maps, documents, and you can convert those into useful information and insights. So you can do things like extract text or tables, spatial features, geometry, rasters, attributes, metadata, and you can convert them to another system as well. So if you want to put them into Excel or GIS or CAD or a database, you can also vectorize data and text from scanned PDFs using OCR and feature extraction. And while you're doing all of this, you can clean up the data that's extracted from PDF, and you can also process the data in a way that's repeatable. So if you have a whole lot of them that you need to have processed, you can set up automated workflows. So thanks for mentioning that one, Brittany. Another one I see here is Andy mentioned getting DWG files into ArcGIS, and we demoed that a bit today. So if you have any questions further on that, feel free to chat them in and we can answer them. Ron asked, what if the CAD line work doesn't have perfect topology? Can you set tolerances? Do you want to comment on that a bit, Jovita?
Yeah, so I used the area builder in mine because my lines were already topologically correct. But if they weren't, I could use an anchor snapper, for example, or use transformers in order to kind of extend the lines and then intersect them back to make sure that they are connected and remove the small pieces that we don't want anymore. I see Dave has answered as well, if he'd like to add anything else.
I just mentioned that there's an option in the area builder to actually pre-snap the lines, and it has a user tolerance that you can set in there. So it's just combining the two transformers into one for convenience.
Nice. And that's kind of the exciting part of FME, I think, that just the ability to do things in multiple ways. There's no one correct answer. Generally, there's a lot of different methods that you can get to your solution by using these sets of tools.
Yeah, absolutely. Thanks, guys. Another one is keeping up with design changes and revisions. That's something Michael mentioned. And this is really important to ensure that everyone is making decisions based on the latest information. Building integration workflows that can keep data up to date in all the systems your colleagues use can be really important for success in the project. And you can build these workspaces using FME Desktop and then publish them to FME Server to be run either on a schedule. So we have customers that are doing things like, okay, there's construction going on in an airport, and so they do a nightly build so that everyone's working on the same map the next day. YVR is doing that. Or there's a lot of customers also using directory watch or other triggers, and that ensures that the workspace is run as soon as new data becomes available. And that's one of the top use cases actually we see for FME Server. So thanks for that really good point, Michael. Then we also have some follow-ups here. So David is asking, what kind of attributes does a CAD require to convert into an IMDF format? That's a really great question. Jovita or Dave, do you want to take that one?
I'll take that one. There's IMDF has a very locked down type of schema. So it's not so much the attributes you have to worry about in the CAD data is more the correct topology. If the topology is very clean for the CAD data, which is quite frankly a rarity for most CAD floor plan files, some of the attributes you need are just simple things like what the purpose of the room is, and say what level the level it's on, which you can usually be gotten from the CAD file itself. So it's not so much, it's not really the attributes usually that's the problem with IMDF, it's the topology itself.
Thanks, Dave. That's a really great question. There's a lot of people using FME to create a digital twin, and IMDF is one of the formats for sure that you would use for that, especially for indoor mapping and indoor navigation, wayfinding. And then people are also using that, aren't they, Dave, for IoT, right? You can set up IoT sensors and place them on an indoor map.
Not so much within the IMDF realm, because that's basically set up with Apple Maps. But if you go to Esri's Indoors format,
Yes.
which is similar, then that's sort of more of a generalized format that you can also bring in, I believe, IoT data as well.
Yeah, that's right. And then we have a follow-up question here from Ron on Brittany's question. So he's asking, scanned plans are raster. Did you say OCR is available? Can you detect lines and convert to vector? So I can answer the OCR question. So OCR is optical character recognition. So basically recognizing text. And yes, that is supported in FME. As far as I know, I think it's the Tesseract collar that you can do that with, Ron. Feel free to check that out on our community to figure out exactly how you do that in detail. And Dave and Jovita, I'm not sure if you have any answers about the detecting lines and converting them to vectors. I believe that's possible as well.
Yes, there's a few methods that you can do that with. The Tesseract collar is one of them. We also have the Potrace collar, and I think it was a raster to polygon coercer. We've got a couple of articles in our community that if you were to search raster to vector, you'd be able to find those. And Dimitri's done some really cool things with the Tesseract collar, so I believe that one's in a blog post.
Perfect, thanks, Jovita. Awesome, I think that's it for the questions that have come in. Does anyone have any last questions for us before we wrap up the webinar? Give you another moment here. So remember, if you do have any questions, you're always welcome to join the conversation in live chat on our website at safe.com and join in the community. That's a great way to get your specific questions answered and look up and see. Usually other people have had the same question as you. And like Jovita mentioned earlier, there are a lot of different ways you can solve the same problem with FME. It's really, really flexible depending on exactly what you need done. So there's a lot of great ideas in the community. And the FME experts team of SAFERs is really active on the community as well. So chances are really good you'll have a SAFER hopping into that conversation. Okay, David came in with another question. Where can we find more resources on FME's CAD to IMDF workflow? Dave, do you want to add to that?
Yeah, there is, I believe, well, the web page for that I created up some months ago is probably a bit out of date in that it uses a CAD sample data set that is unlikely to be, is much cleaner than your data is likely to be. But there is an FME Hub article that you can search. Otherwise, you can contact our support directly, and I'll grab that and most likely help you out directly to get you up and started.
That's right. You've been helping out a lot of folks directly with IMDF. He's our in-house expert on that format for sure. Excellent. Well, thank you all so much for being part of this today. We really appreciate all the questions you sent in. And if you have any questions in the future, please do join the conversation on the community in live chat and come online again with us to join the next webinar. We've got the Ask Me Anything about data integration coming up, so be prepared to have your questions ready and send those in there as well. Thanks so much for joining us today.